like R410A, 407C, etc., they are being phased out in favor of low GWP refrigerants. This change is of course very important for SWEP, the applications, and our customers, and consequently we need to monitor the development of this change. In the presentation, I will cover the main drivers for refrigerant change in different areas, HFC phase down. I will speak briefly about R290, that is propane, the applications we see right now. I will present an application and refrigerant map, a refrigerant matrix, and finally SWEP refrigerant activities. After this, we will have the Q&A, and once again, place your questions in the chat window, and I will try to cover them after the presentation. If we start with the main drivers for refrigerant change, in Europe, we follow the Montreal Protocol and the Kigali Amendment, and that will drive phase down, and it's planned to phase down 85% between 2019 and 2036. However, in Europe, we also have the F-gas regulation, where we have an 80% phase down between 2015 and 2030. I will, in the next slide or next slide, cover this in a graph. We also have the eco-design, which is valid 2018 and 2021 in 2 tiers. And this eco-design, it rewards high seasonal efficiency. It also rewards if you have a refrigerant below 150 and low water pressure drop. Everything contributes to lower emissions and energy consumption. The EN 378 is the safety and environmental requirements regulating refrigeration systems and heat pumps. It regulates what type of refrigerant you can use and what type of charge and what type of safety equipment needed. And then finally, but not least, the prices of HFCs, in particular 410A, 407C and 404A, has increased. They have topped, but it remains on a high level. We can take a quick look on this chart. It's taken from Bayer Ref's annual report 2019. And we have the baseline 100% here, 2016 approximately. Then we saw a steep change increase 2017, and it peaked around 2018. And here, from here, we can see a decline, but we are still at 500% above the compared with the reference level. It's expected to flatten out, but that's only a prediction. Moving over to United States, we have the California Air Resources Board driving the refrigerant change mainly. And you can see this as a Kigali derivative, which will also phase down the high GWP refrigerants. Currently, CARB is followed by 16 states, so it's not something followed by the whole country, but it's expected to spread out over the country. And in particular, from January 1st January 2023, there will be a ban on refrigerants with GWP above 750 in new residential and commercial AC and heat pumps. 2024, there will also be a ban on refrigerants for GWP above 750 in new chillers. And this will drive the change for low GWP refrigerants. Efficiency is governed by ASHRAE 19.1, both full load and part load efficiency. And ASHRAE 15 is the safety standard for refrigeration system, and that restricts the use of A2L and A3 refrigerants. That means flammable refrigerants. Moving over to China, the main driver here, or the overarching driver, is once again the Kigali Amendment of the Montreal Protocol. And here it will be phased out with 80% from 2024 to 2044. So it's a different timeline compared with Europe and United States. China can continue with 410A until 2029 for domestic use. However, low-medium GWP refrigerants are needed for export. We also see that there is a clear policy direction towards low GWP refrigerants in China, and mainly we see use of R32 and R290. There is an efficiency standard governing COP and IPLV for water chillers, and there is also safety and environmental requirements for refrigeration systems and heat pumps. In Japan, also here, the Kigali Amendment will drive the phase out. Also here, compared with Europe, 85% from 2019 to 2036. We see that R32 will be used quite extensively until 2025, 2030, when it has to be replaced by new low GWP refrigerants. There is also an act on fluorocarbons in Japan, revised F-gas law, that states that in commercial AC, that is mainly VRF systems today with R410A, here there is a maximum GWP of 750 from 2020. In commercial refrigeration, there is a maximum GWP of 1500 from 2025. And in large-scale AC, such as chillers, there is no maximum GWP currently. Safety is governed by the High Pressure Gas Safety Act and JRA standards. And in this chart, we can see the phase down according to F-gas and the Kigali Montreal Protocol. The black line here is F-gas. Then we have the green and the purple is for Kigali non-A5 countries. So those are the industrialized countries. And then the blue and the red one is developing countries. And the reference here is 100% 2015, and that corresponds to a GWP of 2,200 in average. Moving down to 30%, we have a GWP of 650 in average, and a 10% or slightly below GWP of 150 in average. So if we try to summarize this, we can see with F-gas, which is the black one here, 2024, at this point, it will be difficult to use R32 and HFO blends, that is medium GWP, after 2024. Moving over to Kigali non-A5, we have 2029 as the breakpoint for 650. And this can be interpreted for US. They have not ratified the Kigali Amendment, and they can continue with 410A. However, with CARB, there will be a phase-out drive where medium GWP refrigerants can be used until 2029. However, after this point, there will probably selection of low GWP refrigerants instead. Looking to China, which is the blue line here, they can continue with medium GWP refrigerants until 2045. Here is a slide on R290 applications, what we have seen so far. And R290 is the same as propane. And it's very much related to the charge of the system. If the refrigerant charge is below 152 grams, there is no safety requirements in the system. You can use it everywhere. And what we see today, it's being used for room air conditioners, like this one here, or in small supermarket display units below 1 kilowatt. And for the supermarket display units, they can be air-cooled, but we also see water-cooled units where a brazed plate heat exchanger is used. In the case of room air conditioners, there is no BPHE use. The next level, charge level, is 0.5 kilo. And here we see a quite clear trend towards supermarket display units, and that is water loops. Brazed plate heat exchangers are used as condensers. And in this picture, you can see a display unit. On the top of this display unit, there is typically one of these systems where you have compressor and a dual brazed condenser. And then you have a water loop feeding the condenser. Next charge level is 1.5 kilos. And here we see applications such as exhaust air heat pumps. They are being mounted indoors, and they use a brazed plate as condenser. You can see here a typical exhaust air heat pump from NIBE. And the reason why they can use so much propane indoors is that it is a ventilated system. Heat is being extracted from the indoor air and then rejected outdoors. So it's continuously being ventilated, and for that reason, propane can be used. Also here, we have supermarket display units, and the charge is very much related to the size of the supermarket. Also here, it's the same design here, but of course with larger components. And then finally, above 1.5 kilos, we have residential air-to-water heat pumps, illustrated here by an outdoor unit from Alpha Innotech. Typically, a brazed plate heat exchanger is used as condenser here. And then also air-cooled chillers and heat pumps can use BPHEs as evaporators. Here is an example from the Italian company Roche-Giani. It's an air-cooled chiller with brazed plate as evaporators. In this application and refrigerant map, we have tried to summarize our view on different applications. I will not go through the full map. I will focus on 3 areas here. And the first is scroll chillers within the segment air conditioners. Typically, brazed plate heat exchangers are used as evaporators and condensers. Today, we see that 410A is still dominant, but in the short term, until 2024, we see that also R32 will become popular together with 410A. We see some indications of 452B and 454B also used in systems, and then there is a possibility that 466A will be used until 2024. This is a new refrigerant developed by Honeywell, but it's not yet commercially available. But the main advantage is that it's an A1 refrigerant with no flammability. Long term, we still see that 410A is being used mainly in China and US. R32 used in APAC, Asia. It's unclear how popular 452B or 454B will become, but both are good candidates. There are some indication that R290 propane can be used in Europe, and this is really a low GWP refrigerant. It has free in GWP and really long-term candidate. And also here 466A is a candidate, and possibly new development can come as well, proposing new refrigerants for low GWP. And as discussed before, we have CARB, we have F-gas Kigali, we have EN378, we have the cost of refrigerant, and we have the eco design. And all these together will drive the change towards low GWP refrigerants. Next application is air-to-water heat pump for residential heating. Typically, brazed plate heat exchanger is used as condenser. However, in reversible mode, it's being used as evaporator. 410A has been dominating until now. Here we see a clear trend towards R32 and R290 replacing 410A. So these three will exist together the coming years. Long term, we have R32 and R290 as the main candidates. And once again, we have F-gas, we have the cost of refrigerant, and we have the safety standards as drivers for the change. The third area is commercial refrigeration in supermarkets. There are quite a few BPHE applications here. We have the condenser, the superheater, gas cooler, and we have cascade heat exchanger and suction gas heat exchanger. There is quite a few refrigerants being used today: 134A, 407A, 407F. We have 744, also CO2, and we have propane. Short term, CO2 and propane is widely accepted and being used, depending on the geographic area, of course. 134A can continue to be used, but can be replaced by 513A with a lower GWP. And then we have these candidates 448A and 449A. Long term, once again, CO2 and propane are really good candidates. We see some larger systems where you have a central plant. There, possibly 1234 SET-D can be used, or 717. Drivers, once again, F-gas, EN378, and of course Kigali as well. In this refrigerant matrix, I've tried to consolidate the different candidates that are available. The dark blue is the reference in every category. So the first part here is low pressure refrigerants. Next is medium pressure, and then we have high pressure in 2 categories. If we start with R134A, we can see that GWP is 1430. It's an A1, so it's non-flammable, medium pressure, 100 in COP in capacity. And it should be noted that this 100 differs from this 100. So this is valid together, those 3, and then these values here are for comparison. So for example, we can see the popular refrigerant 1234 SET EE has only a GWP of 7. It's mildly flammable, A2L. You get the same COP as with 134A, but only 75% of the capacity. And it's being sold under various names. There is a very interesting new candidate here, R515B. It has a low GWP of 293, and it's an A1 non-flammable refrigerant. Similar COP as 134A, slightly lower than 1234, but 72% here. But the most important is that it's non-flammable, and it's a huge advantage for customers choosing a refrigerant. We can also look into 410A here. It has a quite high GWP of 2088. It has the advantage of being A1, non-flammable. Candidates here is R32, quite low GWP of 675. However, it is mildly flammable. It has good properties with regards to COP and capacity. So you can see a slightly higher COP and capacity, of course, depending on the operating conditions. 454B is quite interesting, 466 as GWP, also A2L, very similar to 410A in capacity and efficiency. The new candidate from Honeywell, 466A, has medium-high GWP, so it's a short-term candidate, at least in Europe, but it has the big advantage of being an A1 refrigerant, very similar properties to 410A. Propane, the best GWP of them all. However, it's flammable. It's an A3. It has excellent efficiency, 107 in COP, while only 59% of capacity compared with 410A. So you can see that there is no clear replacement for the old refrigerants, and we have to live with a number of different candidates, and that might be so for some time, and eventually some candidate will emerge as the best selection. So last slide, what are we doing at SWEP with regards to refrigerant activities? Well, SWEP, we continuously monitor the refrigerant trends and development at our customers and other component suppliers. We have upgraded the laboratory in SWEP to handle R32, 452B, 454B, and propane. We have verified a number of BPHE as evaporators and condensers for the above mentioned refrigerants. And then we have also optimized evaporators to better perform with these refrigerants. Then the SSPG8 calculation software, it have been calibrated according to test data for accurate selections. And here you can see a screen from our selection software. So thank you for listening to this presentation. You are free to place your questions in the chat window, and I will go through them one by one. If you want to contact SWEP, you will find your sales representative in SWEP.net, but you're also free to send me an email on erikmenke@swep.net if you have any questions regarding this presentation or to refrigerants. Thank you very much.